Another graphing technique that's available to us is what's called a section, drawing sections. The section is kind of the opposite of what we did with level curves. When we draw a section, instead of saying z is equal to something and fixing the value of z so that we draw a horizontal slice, we draw vertical slices by saying, let's fix one variable, let's fix x or fix y, and then that narrows us down to a little kind of vertical plane inside three-dimensional space. Within that vertical plane, the function will have a graph by letting the other variable change. And by stacking those together, we can get a good, reasonable picture for what the function's doing, like so. So we can think about this instead of producing a kind of like mesh of lines on the surface. So here's an example of the same function we were talking about before, x squared plus y squared, and I screwed up with the equation editor and I don't care. So here's the graph of x squared plus y squared. These lines are sections. So for example, if this is x and this is y and this is z, which is equal to f of x, y, then one thing we could do is we could fix the value of x. We could say, what are the solutions when x is equal to 0? And that draws for us a little graph. It's going to be this line on the surface. If we instead fix what happens when x is equal to 1 or when x is equal to 2, we're going to get a slightly different line on the graph. And I can see that I've messed this up slightly. I'm just doing my best. And as we do better and better approximations of those, we can get a better picture of what's going on the surface. Or if we go in the other direction, we can say, what happens when we fix y? Then we're going to get a graph as x changes. That's going to give us a little slice like one of these lines. And as we put those together, we get the other direction of the mesh. All right. So here's an example of this at work going backwards, just starting with this, saying z is equal to x squared plus y squared. When we set y equal to 0, we get the graph of a parabola. Z is equal to x squared. That's this one in the middle. Y is equal to 0. When y is equal to 1, we instead get a parabola. Z is equal to x squared plus 1. It's still another pretty standard parabola. It's just slightly higher here. And when y is equal to 2, we get a parabola x squared plus 4. That's again similar, but even taller yet. And the same thing is happening on the other side. So here's 5 different sections we've drawn of this graph. We can tilt them and stack them together so that then inside three-dimensional space, they start to give us an approximate picture of what's going on with this function. And this is an imperfect procedure, but it does give us a tool to try and access what the function is doing.